welcome to the day one of a new topic, that is quadratic functions. So quadratic functions as a topic we have already dealt with in grade 10 as well. So now in grade 11 we are going to take this topic to new heights. But first of all, in the next few classes, maybe 1, 2 or 3 classes, we are going to recall everything that we already know, and it is very important because whatever we are going to do after that, it is completely based upon what we already know. So let's first recall from the very basic thing, that is the function which is fx is equal to x square. So first just have a look at this basic understanding. So listen to every word very carefully now. We already know that this y is equal to, let's say fx is equal to ax plus b. ax plus b. If this function is drawn, then this results in a straight line. This is a linear function. So this is the example of a linear function. We know that whenever this is drawn, then ultimately the graph would be a linear function, a simple straight line. Similarly, we know this shape as well. Let's say x square plus y square is equal to 16, which results in a circle whose center is 0, 0 and radius in this case is 4 square. So radius is 4 for this circle. So these two shapes are sort of known to us. So then comes this new name, which is not exactly very new to you because you have even heard about this name in grade 10th actually. So this new name is, which starts from this basic function, let's say y is equal to fx is equal to x square. So the new name, the new shape which we are going to discuss right now is a parabola. This is our complete task. So in order to understand the quadratic function completely, we have to understand in depth the shape of this figure parabola. So just like circle is a known figure to us. Straight line is a known figure to us. So now comes the new name, that is a parabola. So parabola is actually a curve like this. It's a curve like this. So if I draw, so the interesting part is this, that in general, any quadratic expression which we are going to deal with in detail in today's class itself, actually takes the shape of a parabola when drawn. So actually a quadratic function when drawn on graph paper, it results in the shape of a parabola. It is a parabola actually. So how does a parabola looks? For that I have taken a very basic example, that is y is equal to fx is equal to x square. So if I draw this function, so if we can recall, we already know the graph of this function, which is actually over here. So this is the graph of y is equal to x square. We have seen this graph. So this is actually the shape of a parabola. It is always like this. So a parabola has some specific points which we need to understand, and from now onwards we'll just completely recall those very simple names. So just like in a circle, what is special about a circle? What points are always to be recalled while dealing with a circle? They are the centers of the circle and its radius. So these are two basic names which we have to remember whenever we are talking about a circle. Whenever someone tells me that okay, there is a circle in coordinate geometry or wherever we have drawn a circle, so my next question is that what is the center of that circle and what is the radius? So similarly, when someone talks to me about a parabola, so in that case the points which just should be coming to our mind are actually these points which we are going to list right now. So for a parabola, the main point which we should be clearly focusing upon is the point where this parabola is bending. Can we see that this shape is bending? For any parabola like this one or maybe this one, we can see that at this point this parabola is changing direction. It's going from here to here or from here to here. So this point where this parabola is clearly changing direction, this is known as the vertex of this parabola. So this is known as the vertex of this parabola, V-E-R-T-E-X. This is the vertex of this parabola. So just remember this word from now onwards. So this point is the vertex of this parabola. So for this basic example which we have taken, the vertex of this parabola is at this point, which in this case is the origin, which is 0, 0. It should not necessarily always be at 0, 0, but at this moment it is at 0, 0. And this parabola has a direction to it. It is either opening, let's say, upwards or downwards. It could open in different directions as well. But for a simple quadratic function that we are going to deal with, it would either open upwards or downwards. It would either be of this kind, opening upwards, or like this type, opening downwards. Look, just notice that this one is opening upwards, this one is opening downwards, this one is also opening downwards. So these are the vertices of this parabolas. This is the vertex. This is the vertex of this parabola. This is the vertex of this parabola, and this is the vertex of this parabola. Similarly, we can see that this parabola is there is a line exactly in the center, which is in a way dividing this parabola into two symmetrical parts. The two parts which are exactly the mirror image of each other. So this line is known as the axis of symmetry. Axis of symmetry of this parabola. So this line is the axis of symmetry of this parabola. This is the vertex and this is the axis of symmetry, and it is opening upwards or downwards depending upon the situation that has been asked. So this is like the basic structure which we need to understand before moving any further. So now we have understood some basic new points if they are new to you. One is the vertex of the parabola, one is the axis of symmetry. So in this case, this is the axis of symmetry. 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 Over here, this is the vertex and this is the axis of symmetry. So we need to understand this very basic logic first of all before diving further into this topic, that is quadratic functions, which would always, when drawn, would be a parabola. And we would be able to solve so many questions with ease after understanding this basic logic with full confidence.